Welcome to the premiere of Project NOTUS, a first-of-its-kind approach to bring the reality of virtual site due diligence to Korea. To produce the top-quality, multi-dimensional film of Project NOTUS's 4 wind energy assets across the states of Nebraska, Texas, and Illinois, wind energy experts from Orchid Group with instructions from and reporting to Korea Ratings worked alongside independent professionals in video production, drone navigation, aerial photography, and sound design for critical industries. Coordinating with the asset owner, Terraform Power, and the operator, GE Renewable Energy, the team visited all 4 sites between July 28th and August 4th and interviewed Terraform's Vice President of Operations and the GE site manager of each wind farm. Getting up close and personal with the workers while recording their answers and thoughts, the team captured detailed explanations of each site's operations.
I'm Whitney Wilson. I'm the Vice President of Wind Operations for Terraform Power, a Brookfield renewable company. I've been working in the renewable energy industry for more than 15 years. I started my career as an independent engineer, working with a couple of the largest independent engineering firms in North America. I've known from the beginning that I wanted to do something that was environmentally conscious. And so that's one of the reasons I really love doing wind energy. I'm responsible for all of the profit and loss, all of the day-to-day operations of our wind facilities across North America. I'm responsible for all of the major component work that's done, and I run all of both the operations team that's out in the field, as well as the asset management team back in the home office.
My name is Aaron Wyatt, and I'm the site manager at Prairie Breeze. I have just over 6 years total wind experience managing wind farms. As a site manager, I'm responsible ultimately for the entire operation of the plant, the facility, including all the turbines and the substation. So it also includes inventory management as well as personnel management.
My name's Kevin Valentine. I'm the site manager here at Rattlesnake Den Wind Farm. I've been in wind for about 3.5 years. I was a site manager for a previous company and took over Rattlesnake Den in November of last year.
My name is Justin Lappin, and I'm the O&M manager at California Ridge Wind Farm. I have been in the wind industry for about 6 years, and I've been the manager here at Cal Ridge for GE for 1 year.
My name is Andrew Morrissey. I am the Bishop Hill site manager for General Electric. I have been with General Electric for roughly 1 year. I have been in the wind industry since 2007. My roles and responsibilities with General Electric is the O&M site manager. I started as a technician. I got to see how the turbine operates, how to manipulate the machine, and go from there. The coolest part about being where I am today, I get to see it more full circle.
My name is Ryan Fonbuena. I'm the Senior Manager of Field Safety and Security for Terraform Power. I've been with Terraform a little over 2 years now. So I started working for Terraform in first quarter of 2017. Came over to Terraform by way of SunEdison. After SunEdison had acquired First Wind, started working for First Wind in 2006 during the construction of the Mars Hill Wind Farm. So worked in Maine for a few years. Prior to that, I started with Enexco before they became EDF in Northern California in '98. Come out to these wind sites, every wind site at least once a year. Some of them I'm able to get out to more than once. Do some audits, meet the teams, see how the facility's operating and how the guys are getting along.
Beautifully located north of Nebraska's Bohemian Alps, the Prairie Breeze Wind Farm sits near the small town of Elgin, Nebraska, with turbines installed in Antelope and Boone counties.
Prairie Breeze has 118 GE17 turbines. It's located within the central region, or the Great Plains region, which has a high wind penetration and a large amount of quality resource.
The local area consists of corn and soybean farmland in rolling open fields used for cattle grazing and agriculture with occasional trees. The nameplate capacity of Prairie Breeze is 201 megawatts. 100% of the power is purchased by Omaha Public Power District. Situated in the rugged flat terrain of West Texas and the Permian Basin, World famous for oil and gas exploration and production, the Rattlesnake Wind Farm is located about 45 miles southeast of the city of Midland in Glasscock County. The acreage Rattlesnake occupies has multiple uses: wheat and cotton crops, cattle operations, and oil and gas exploration and production. Pump jacks, processing plants, pipelines, fracking facilities, and infrastructure dot the landscape for miles and miles, extending beyond the horizon.
Rattlesnake Wind is a facility located outside Midland, Texas.
The nameplate capacity of Rattlesnake is 207 megawatts. Power produced from the wind farm is sold into the Texas ERCOT market at merchant rates. Constructed among fertile farmlands, the California Ridge Wind Farm is located in Vermilion and Champaign Counties, Illinois, about 25 miles northeast of the city of Champaign. Turbines are installed in both counties. The project area is comprised primarily of flat, sparsely populated rolling hills used for corn and soybean crops and livestock breeding.
This site is located in the Great Plains with quality wind resource and close to a load center, with Chicago being about 2 hours away.
The nameplate capacity of California Ridge is 227 megawatts. 100% of the power produced is purchased by Tennessee Valley Authority. Surrounded by gentle, rolling hills filled with corn and soybean fields and livestock, the Bishop Hill Wind Farm is located in Henry and Stark Counties, Illinois, centered around the small town of Bishop Hill. Turbines are erected in both counties. Gentle farmlands surround the project, divided into north and south clusters.
The site has 133 GE turbines, a mix of GE 1.5 82.5 meter turbines, 1.6 82.5 meter turbines, and 1.6 100 meter turbines.
The nameplate capacity of Bishop Hill is 218 megawatts. Tennessee Valley Authority is the power purchaser.
These sites were developed by Invenergy. Invenergy did all of the original studies and the development of this. Terraform and Brookfield Renewable Power bought these as part of the acquisition of Terraform in October of 2017. The sites are manned by GE technicians during the daytime hours, as well as on-call GE technicians for anything that should happen outside of regular work hours. Those technicians are responsible for that day-to-day piece in contact with the Terraform management team, so our regional operations managers then oversee those GE technicians and make sure that everything is functioning and operating in a manner that is consistent with the Brookfield approach, the Terraform approach, and our overall business plan.
While many Korean investors have experience investing in wind energy, for others this may be their first foray into the sector. Understanding the major equipment and key components in a wind energy operation is important for differentiating between strong wind businesses and those that are less successful.
A wind farm is an operational energy facility that allows energy to be made from the wind and turned into electricity that goes onto the grid and powers homes. In any given wind farm, you're going to be spread out over a large area. Each turbine itself, including its roads, collection systems, takes up less than an acre of land, but they're going to be spread out away from each other, so you're going to be over an area of 3,000 or more acres of land for the entire project. There are pre-construction Met towers that are placed when you're doing development that lets you understand the wind regime at the site. So you'll be able to understand the wind speeds, the directionality, turbulence, how bumpy is the air. So this lets you design the facility in a way that you can separate the turbines so that they're apart the best way they can to make them perform optimally. This also allows you to set up essentially what are rows of turbines directed at the wind in the right direction so that, again, you get optimal performance for the smallest amount of overall acreage. However, each individual turbine is its own Met tower. Every turbine has a wind vane, it has an anemometer, and they're each doing their own meteorological data instantaneously as well.
We are standing in the base of the 16100 unit, and this is the DTA assembly, as they call it. It houses the converter unit that actually does the conversion of the energy from up tower to be able to send it into usable power back to the substation. So up tower, inside of the generator, the rotor is producing energy. It is turning that mechanical energy into actual electrical energy that is sent down here. The converter cleans it up. It goes through different cables down under the basement under our feet and sends it out to the pad mount transformer that's outside of the tower. This is where the turbine sends the energy through to be stepped up to a higher voltage to be sent back to the substation. The rock in between these two fields that you're seeing here are access roads that the technicians use to access the turbines daily to do troubleshooting and maintenance tasks. They lead all the way out to main roads typically that eventually will lead you back to the O&M building.
This is the Bishop Hill 1 O&M building. This is pretty typical for a wind farm operations and maintenance facility.
So the operations and maintenance building houses all of the offices for the technical staff, the technicians. It houses the spare parts storage, and it houses any kind of machining and tooling that we need. So this is the building that's really the heart of the operation of the facility. This is the place where you can come and you can get all the parts you need. You can find tools that'll help you do your job correctly. So it's there to be able to make sure that we can operate effectively and efficiently, and we don't have to wait for parts, we don't have to wait for tools, we're able to get them immediately as we need them.
This is the Bishop Hill substation. This is where we collect all of our high voltage electricity off of the turbines. All comes down into the substation. We're working with 34,500 volts. A lot of electricity. You can hear it. This is where all of our turbine collection comes into. The turbine out in the field produces the electricity. It comes underground, collects all into the substation yard. They come into here. They go into a circuit breaker, which essentially meters the circuit itself. And what happens is if we find a fault or if a fault occurs within a turbine, that breaker would open up and disconnect the rest of the substation from that feeder. So as you'd see in your house in a junction box, you have breakers. This is essentially the same thing on a much larger scale. It goes through the feeder breaker, up to an overhead, ties into the transformer, which is this unit here, steps it up, pushes it to the high side of the substation, and then goes through overhead distribution lines to our interconnect. These darker towers behind me are our interconnect lines that come off of the substation. This runs overhead, carries all of our high voltage lines.
This is where our produced energy gets introduced into the grid. You can see the same big poles that we saw earlier where the power ties into the final grid where it goes to power our homes.
Each wind farm interconnects with the transmission grid that is operated by an independent entity that is responsible for grid reliability, safety, and security, as well as monitoring in real time the power produced by each generation source connected to the grid. There are 4 independent grid operators for Project NOTUS. Prairie Breeze interconnects with the Southwest Power Pool System in Nebraska, otherwise called SPP. Rattlesnake interconnects with the Electric Reliability Council of Texas, known as ERCOT, whose command center is in Austin, Texas. California Ridge interconnects with the Midwest Independent System Operator, referred to as MISO. Bishop Hill interconnects with the Pennsylvania, Jersey, Maryland Power Pool, referred to as PJM. The power purchaser, also called the off-taker, communicates with the wind farm and transmission grid operator daily to request and order the amount of power it is expecting to receive, and to confirm the quantity actually produced from each source. Wind power generation is an intermittent resource. It is not dispatchable. Therefore, the grid operator records the actual amount of power produced against the quantity requested by the off-taker and consumed by the market to ensure supply and demand are in balance on the transmission system.